Hi, everybody, and welcome to another exciting RCI Science event on every Canadian's favorite topic, weather. I'm Dr. Suzanne McDonald. I'm the chair of RCI Science, and I'd like to first acknowledge the land that we're virtually meeting on is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis people. We also acknowledge that Toronto is covered by Treaty 13 within the Mississaugas of the Credit. Today, this meeting place is still home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. And we know that we have viewers from across Canada and beyond, so we suggest that you research the history of your land using the website and app native-land.ca. And I hope that wherever you are in the country, you're experiencing a taste of spring like we are in Southern Ontario. Well, today we have an exciting panel. I have been waiting for it all week, moderated by Nadine Powell. We love talking about weather. So Nadine is going to introduce our experts. We're going to have short presentations by them, and then we're going to have a moderated question and answer period and take your questions from the audience. So you can submit your questions, your comments in the chat box, or your comments via Twitter at RCIScience, or by email to information@rciscience.ca. And remember, be polite and respectful. We do have moderators monitoring the chat, and we will take action as appropriate. Without further ado, it's my pleasure to introduce our moderator, Nadine. Nadine Powell fell into weather by accident and loved it so much that she stuck with it. She graduated from the University of the West Indies with a BA degree in geography in 1996, where she found weather to be one of the fascinating components of geographical studies. After working for the Meteorological Service of Jamaica, followed by the Caribbean Institute for Meteorology and Hydrology in Barbados, she began her career as a TV weather presenter at Television Jamaica in 2000, and in 2002, she emigrated to Canada and began as a presenter at City TV Toronto, and then went on to Global TV Toronto. She has been at the Weather Network since 2008. I'm a huge fan, as both a briefing meteorologist and an on-camera presenter. During her time at the Weather Network, she also completed a BSc degree in atmospheric science at York University. Yay. Over to you, Nadine.
Well, thank you so much, Suzanne, and good day to all of you, and a good day to our panelists, whom I will introduce in just a short bit, and a good day to all of our viewers, wherever you are joining us from. So I think that our topic today, the way it's headlined, is it's a bit of fun, and it summarizes our relationship with weather, the science of weather forecasting. It sounds very sciencey, very logical, and for most of us, it's not only serious, but it can also be fun as well. Hence, cloudy with the chance of meteorology. Well, over the years, the importance of not only short-term weather, but also long-term climate has become very important. It's a huge topic of conversation, especially in these times. And today, our three panelists will be getting into a bit of weather, a bit of climate, and we'll also be taken along on perhaps a little bit of a storm chasing adventure. So our first panelist is Johanna Wagstaff. Johanna is the meteorologist and science reporter at CBC Vancouver and CBC News Network. Wagstaff's academic background in seismology, in earth science, that has led her to cover major earthquakes, wildfires, hurricanes, floods, and the Copenhagen, Paris, and Glasgow climate change conferences. Johanna has hosted 3 award-winning CBC podcasts, including Fault Lines, 2050 Degrees of Change, and is the author of several children's science books. It's very exciting. Mm-hmm. Please welcome Johanna Wagstaff.
Hi, everyone. Nice to be here. Thank you so much for having me. I am coming to you from the beautiful and unceded territory of the Squamish, Musqueam, and Tsleil-Waututh nations, and I am thrilled to be chatting to so many, I'm guessing, fellow weather weenies, because meteorology is a topic that affects and fascinates so many people. And I'm also thrilled to be chatting with fellow panelists and Nadine, who I have immense respect for. As you'll find out through our talks, it's such an amazing community when it comes to meteorologists across the country. I wanted to start you off with a little video, though. Not quite archival footage from when I first began, but it's close. Take a look at one of the first TV forecasts from CBC. This is Percy Saltzman, meteorologist in the 1960s. Oh, hang on. Let me just play that.
It hasn't been a delightful day anywhere. And the reason is the map is lousy with lows. Now, yesterday there was one here and one here. They've converged, and in effect, the larger has swallowed the smaller, and there's the low at the moment. And this is the frontal setup as a result of the low, with the cooler air coming in this way, the warmer this way, and of course, the
what Percy is doing right now for a TV audience, using chalk and a chalkboard,
all of Ontario, good part of Quebec,
we don't quite use today.
American states. That leaves the high pressure out in the east, governing the weather there and producing clear and
But I love that he's using science to communicate the weather, which is what we still use today. So I'm just going to mute this, but let this continue to play in the background, because, you know, this many decades later, the science of weather forecasting really hasn't changed that much. You know, Percy is showing you the location of our pressure systems and our fronts, and he's moving them forward through time to give you his best estimate of the forecast for the country. That is an excessive low that he is circling right now across the prairies. And I just love that with all of our advancements in technology, the basics of weather forecasting really hasn't changed that much. So I know many of you are probably well versed in this, but I wanted to give you a little bit of a 101 on short range weather forecasting. I have always loved weather and science and the processes of the earth. It was actually through getting my pilot's license that I became really interested in forecasting, because as part of the process to get your pilot's license, you have to learn how to do a bit of basic forecasting by reading the clouds, doing a little bit of analysis ahead of time. And for me, that was just so amazing that as an individual, you could do a mini weather forecast on your own every day using available tools to come up with a hypothesis. And that's what hooked me. So I just want to show you a little bit about the basics of weather forecasting. Again, that hasn't changed that much in the decades since Percy Saltzman first started. So the basis of all weather forecasting, short range weather forecasting, comes down to measuring the weather right now on the ground. That is what we call our current or initial observations. And we use a variety of tools to get the current weather for different points all around the world. We use, of course, the weather station. We have official and non-official weather stations that take all of the basic measurements of the atmosphere: temperature, humidity, wind speed and direction, pressure, and precipitation. And these are fed into a network that meteorologists can access. And this is probably the most common tool for current observations. We also use weather balloons that help us figure out what the current observations of weather is at different altitudes in the sky. And these are released twice a day around the world. I think we have over 30 of them here in Canada. We also use observations from weather buoys that, again, take those initial conditions from the ocean. I really rely on that out in British Columbia. We use satellite data to get a picture of what's happening right now from space. And our initial conditions are expanding every day, which is making our forecast better and better. We're using data from airplanes as they take off and land. They're feeding back those initial conditions for us. And more creative ways to get those initial conditions are advancing our accuracy every day. One of the ones that a lot of people are talking about is using conditions from people's smartphones, because the better network we have of initial conditions, the better our forecast will be. Number two is entering all of these initial conditions into weather models, which is basically the equations that we know about how our atmosphere works. So plugging all those conditions into basically a supercomputer that run those equations about how the atmosphere moves over time. And then it comes down to interpretation. But I just want to show you these two graphics for a moment, because one thing that is changing that I'm happy to deep dive into later on is the difference between deterministic and ensemble forecasting. And I like to think of it, for any Marvel fans, like metaverse. So the way that so many meteorologists have forecasted for so long is deterministic, which is sort of a snapshot on the left. That's taking all those initial conditions, which don't cover the entire globe. So we have to interpolate and make estimates about initial conditions in places that we don't have data. And then we end up with one picture of what the atmosphere looks in the future. This is a picture of North America. It's showing you where the precip and pressure systems will be in the future. On the right is an example of an ensemble forecast. And this is becoming more and more popular, and it's making our mid to long range forecast, so anything past 3 to 10 days, more accurate. And you might have heard or seen these as spaghetti plots. So it basically takes those initial conditions and just alters them slightly. So you end up with solutions that are slightly different, but we do this hundreds of times. So you can see on the right there that we get an array of different answers, and we're able to take the average of those, which is much more accurate. And I like to think of that as all of the different possible multiverses is available to us. So that's really how forecasting has changed significantly in the past few years. Our supercomputers are getting better, and we're getting better at those initial conditions. But interpretation is still key. We need people to take all of that data because there is so much data. And this is where my love for forecasting really comes in, is deciding what data you want to use in the time frame that you have for the forecast you have. And I know all of us panelists probably make different decisions based on our audience, based on the location that we're forecasting for, based on whether we're forecasting a weekend forecast versus severe weather versus long range climatological data. We will interpret that differently. And that's why humans are so important behind the forecast. But before I wrap up, myself as a meteorologist, the industry has changed immensely in the 15 years that I've been forecasting. You know, when I first started there on the left, and maybe some of you recognize some of those Toronto meteorologists there, there's Anthony Furnell. It was a one-way conversation. We spent the whole day forecasting for the 6 o'clock news, broadcast meteorologist. And now this two-way conversation we have, where we're able to get instant feedback, instant forecast verification, and the negative side of social media has really changed my job. I'm forecasting 24/7 in some cases. But what I love about meteorologists is that sense of community. And even though all of us panelists, are in competition with each other in some ways, when severe weather or life-changing weather is on the table, we come together to share the same message. And I just want to end on that note, that climate change is changing the role of meteorologist. And I think for many broadcast meteorologists, we are the one interface that the audience has with scientists. And I do think for myself, it's part of my job to help communicate climate change, because weather is how people will and are experiencing climate change. And in my 15 years, especially out here in British Columbia, we've had back to back extreme weather events just in the past 10 months that have devastated our communities. And, the concept of climate and eco-anxiety is real. And it's going to continue to be a challenge, but one that I'm hoping I can continue to step up to and work with my fellow colleagues on that communication. So thank you very much, and looking forward to your questions.
Well, thank you so much, Johanna. You took us through so much information. It is a lot to process, in the day-to-day workings of a meteorologist. You touched on, some very important points, especially, in these times with social media. During severe weather, we can, rely on, the public. They can give us, like you were mentioning, Johanna, the ground truth and the verification. So speaking of severe weather and tornadoes, we'll segue into our next panelist. So a bit of fun stuff here. So second to the US, Canada has the highest number of tornadoes worldwide. Our next panelist, Neville DeMiliano, is the co-founder of the Prairie Storm Chasers, a group dedicated to targeting, documenting, and reporting severe weather across the Canadian prairies and Tornado Alley in the US. He also enjoys speaking at schools and universities about the science behind storm chasing. It is a pleasure to welcome Neville DeMiliano. Neville.
Thank you so much, Nadine. I'm so happy to be on this panel and chatting weather today. It's really nice here. I'm in just outside Edmonton. It's a really nice day here, so I'm always happy to talk weather. And let's jump right into the presentation. I got a bunch of slides to go through and maybe a quick little storm chase that we can virtually go through together, hopefully. But I'm always curious what you're most interested in. So if you want to just toss your answers in the chat. I already see some C's and A's coming in, so perfect. Yeah, I'll jump right in. I'm on a team of 5 people. Prairie Storm Chasers is Braden, Beth, Sean, and Chris, and myself. And we kind of pursue severe weather across the Canadian prairies and into Tornado Alley. Start with an easy question: is what is storm chasing? Well, really, if you've seen the movie Twister, it's not far off from what's depicted there. Obviously, if you take out the Hollywood in it, there's a lot of long drives and things like that you wouldn't see, but really it is kind of like applied field meteorology is kind of another way to call it. And what comes with that is also like, how do you storm chase? So Joanna, it's great that you did that little segment first, because we rely on a lot of the same tools as weather models run by supercomputers is a big tool for us to be able to pinpoint where we need to be upwards of a week away from when a storm might come. So we're using those. And then we're also using, on the day of an event, we're using observations like satellite images, radar, which is like a X-ray for storms to see the shape and size and how they're moving and if they're getting stronger. And then obviously, to keep us safe, armored storm chase vehicles. So this is the Dominator 3, probably like the world's most famous storm chase vehicle. It's a slightly modified Ford 350 truck. And it's got armor plating, special windows that shoot up to protect us from debris. It's owned and driven by Sean Schofer, one of our team members. And the newest addition is that rocket launcher on top, which can actually shoot weather instrumentation into storms and tornadoes to gather really important data. Because really some science still doesn't know why certain storms will produce these tornadoes and some storms won't. So that data can be valuable from that perspective. The design of Dominator is so that the wind can go over top of it rather than underneath it and flip it. So it also has road spikes to anchor the vehicle down. But obviously not all storms are ones that we can go into with the Dominator. There's still a limit, so always have to be safe that way. This brings me to like the why chase. I think a lot of people always ask, like, are you crazy? Why do you chase? And I think everyone's why is a little bit different. Some people just really want to see weather at its most dynamic. I think some people want to test their photography and videography skills. Some people are researching weather. For me, it came from a place as a kid growing up and seeing a storm, one of the more famous storms in Canadian history, the Edmonton Black Friday tornado. And I wasn't even around for this tornado yet, but my parents had newspaper clippings in the basement, and I think I came from a place of fear of storms like this. Anytime there was a thunderstorm, I think I was a little bit afraid, and then that kind of translated into intense curiosity as to like, why are these storms happening? What makes them tick? And understanding that helped me not be as afraid of them. And I think one thing led to another, and I just wanted to see more and more of these storms. So that's what led me to storm chasing. But the big reason why for being out there to me is really to help meteorologists like Joanna or anyone who's trying to warn the areas that's in front of these storms as they're progressing. So radar is a big tool for Nadine or Joanna to use while they're communicating the weather and these severe weather alerts and things like that. But the lowest part of the atmosphere in that red box, that's what you can't see with radar. So the meteorologists looking at their data can't see what's going on in the lowest part of the atmosphere. And that's where those big hail events, big wind events, and tornadoes occur. So that's where the spotters or storm chasers come into play. So the reports from trained spotters or storm chasers can really go a long way in helping that warning process and keeping people safe, hopefully. But let's go on a quick chase just to test it all out. So imagine you kind of roll up to a scene that looks like this. So it doesn't look that scary. I mean, I showed that picture of the Black Friday tornado. That was pretty menacing, but So you roll up to on a country road, you kind of see this happening in the sky. What do you think is going to happen next? There's a couple options. You can put your answers in the chat. So is it going to be A, a big lightning bolt, B, a deadly tornado, C, nothing, it's not even raining, doesn't really look like it is, and or D, is there going to be some big hail? Okay, got all your answers in the chat. Good. I see them coming in, and let's find out what happens. Yeah, so a big tornado. It didn't really look like you'd expect that from that storm, and that's where a lot of that experience and training kind of comes in. We'll go back to that initial photo in a second, but I just wanted to highlight, like, this was a significant tornado and storm event, and it really happened very quickly in Manitoba. Unfortunately, this was a deadly tornado in that it did end up hitting someone who was traveling on a road nearby, and so there's that to consider. So these are beautiful, inspiring, but also like violent and deadly storms occasionally. So there has to be a healthy fear and respect and knowledge when kind of chasing around them. Oh, if we go back to this first photo and look closely, I mean, this is the kind of shape that we're looking for a storm to do. You can kind of almost visibly see it rotating, even though it's just a still image. And right in the kind of side here, if you can see my cursor, there's actually already a bit of a dust swirl on the ground. So this is a process that we call like tornado genesis, and it's already underway. So if you're a storm chaser, you're probably getting ready to report this storm as about to produce a tornado or in the process of producing a tornado, so that the areas in the path of it will get that warning, hopefully in time, and be able to take action. But obviously, if you're on the road, like, you got to be weather aware in some scenarios, because you just never know when these things are going to happen sometimes. And this all happened really quickly. So the kind of whole topic of that I thought was really interesting for today's talk is, like, weather forecasting, is it science or science fiction? And sometimes it feels like science fiction, but I think that that's from the fact that it's so good. I think that a lot of forecasts are incredibly accurate. I mean, we rely on them a lot, and when they're wrong occasionally, I think we give the meteorologists a bit of a tougher time than they really need. But that's kind of a testament to how good they really are. And to kind of illustrate this, it's amazing how little has to change or come together to go from a day that looks like this on a storm chase. We're really, like, it feels like we're driving obscene amounts of time, and the only thing we end up chasing is a bottle of sunscreen. Because it happens. And when you're dealing with all these, like, delicate balances of all these ingredients that need to come together for the perfect mix to get kind of these rotating thunderstorms that maybe will produce a tornado, there's a lot of downtime. So one of the questions was, how close is it to, like, Twister in real life? It's Twister, but they don't show, Twister's maybe the trailer, and they don't show the movie or the filming, which took like 14 hours of driving to get there. And sometimes you just get a suntan. So yeah, there's a lot of days that are pretty boring. There's a lot of times that are pretty boring, but it is all worth it when it all comes together. And there's really that delicate balance. It goes from a day where we're just getting a suntan to something like this. So there's not a lot that could be different, but you get very different kind of days. Chase days. Sometimes you get no storms, and sometimes you get a mediocre storm, and sometimes you get 5 tornadoes in a day. And we still really don't know what to expect each day, so we go out hoping that we'll get that. I'm going to whip through this pretty quick, but I think that the climate conversation is really interesting, because I think that using some of this data now and going and using climate data to go back and look at historical events. I talked about my why being the Edmonton tornado. There's some really interesting research that took some of that climate data to kind of use modern tools to be able to produce that graphic you can see on the right that highlights exactly where the biggest threat for a violent tornado might be on that day. So if we had tools like that back then, would have made a difference. Would less people have been injured? Would less people have died? Would there have been just more warning time, better communication? I think so. And that goes back to my why. Better forecasts, more specific alerts. I think it's really interesting. So go back to this day, and this is the kind of timeline of events. And I think maybe this timeline looks a little bit different. Maybe the language is a little bit different. I think Joanna talked a little bit about the communication. Maybe instead of heavy thunderstorms, they're already talking about tornadoes in the day or the hours leading up to this storm. And maybe that makes a difference. And I do truly think it will. And thanks so much. That's it. Thanks so much for having me. I'm excited to talk on the panel after this.
Well, thank you so much, Nevin. A lot of questions are coming in already regarding tornado chasing and the storms that you track. You mentioned the movie Twister. I think you answered that question, but just one quick question, and keep the questions coming as well. So all of our viewers, one of the questions is how close do you actually get to the tornado? And where can, say, an enthusiast or someone who's interested in the field get, spotter training or, storm chasing training? Where can they hone their skills and their knowledge?
Sure thing. Great 2 questions there. So how close do we get? It depends on a lot of things. It depends on all the ingredients that are coming together to that day. What are we expecting? If we're expecting a tornado like the Black Friday tornado, obviously you don't want to get very close to that. Even a vehicle like the Dominator, you do not want to go into a storm like that. It's just the winds and everything is just too intense. So it all depends on the different factors. But I think having the right safety tools and things like that can kind of gauge, and also the experience. For me, I like to stay a little bit further back. Some of the other people on my team like to be a little bit closer. It's experience and comfort level, and so there's a lot of different variety strategies that can go into how close you want to chase. And the second question was spotter training and things like that. There's a lot of great online resources. I would suggest if you go to our website, I threw a bunch together, prairiestormchasers.com, and they're all together there if you want to check that out.
Well, thank you so much, Nevin. So we look forward to more questions coming in, and we'll be chatting about that coming up in just a bit. So we're going to move on to our third panelist. We'd like to welcome our third panelist, Alexandra Clark.
Yeah.
Alexandra worked for Temagami First Nation as their climate change researcher, looking at how climate change is and will impact the vibrant remote island community accessible by ice road during the winter. She is passionate about spreading science-based education and awareness, and recognizes a great need for all communities to have the capacity to look at the effects of climate change and its cumulative effects. Please welcome Alexandra Clark.
Hi, I'm very happy to be here today. I'm coming from the traditional territory of the Teme Ogama Anishinaabe. I worked on climate change and cumulative effects research here for the past 2.5 years, and I've been on many adventures, including to the highest point of Ontario, Ishpetina Ridge. So Temagami is a lovely island community located in northern Ontario, about 450 kilometers or just under 5 hours north of Toronto. You wouldn't think that the weather is that much different, seeing as it's really not that far on the map. It's not even, it's just not very far away. So you'd think it'd be pretty similar. But just 5 hours north of Toronto, you can drive on an ice road with your passenger vehicle. So last time I drove on the ice road was March 30th of this year. I drive an SUV, and it's about a 5-kilometer drive one way, and the scenery is spectacular. A TFN community member recently posted some ice measurements from Friday, April 22nd, and there's still about 14 inches of ice in the part that he was looking at. And I was there at the landing taking a look at what people were doing, and I still saw snowmobiles driving across the lake. So why am I talking about an ice road? Well, the weather determines when the ice road becomes stable enough for travel, and climate determines if we should be able to expect ice roads from year to year. I've looked more at how weather and climate affect people and the environment as opposed to how we predict it in the research that I've been doing. So, to gain more perspective, we need to define weather versus climate, and you can't really talk about one without considering the other. The difference between weather and climate is a measure of time. Weather is short term atmospheric conditions, typically over days to months. An example is rain yesterday, or the weather forecast we hear on the news or check on our phones usually. It's important information that we take in on a regular basis that helps us make informed decisions. So, do I need an umbrella today? Is it time to switch the snow tires to the all seasons on my car? Or how heavy of a jacket do I need when I'm leaving the house in the morning? So, climate is kind of like your longer term predictions. It's just kind of like something that you see like, over 30 years. So, when we're talking about climate change, we're talking about changes to the long term averages and trends for daily weather. So here we're looking at a temperature graph of Toronto. This is December 2021. We can see that their lowest was in around the end of the month there. It was about -7. In this next graph here, we're going to look at the temperature in Temagami. This is the same time period, this past December. And we see that the low at the end of the month there was around -27. And this is when the ice road was really starting to build up, and we were starting to see snowmobile travel in around that time. And these cold temperatures are really important for, having that ice form. So I know that these two graphs here, they look pretty similar, but I just want to highlight that there's like a difference in the scale here on the left-hand side. So back to the ice road. The ice road provides essential seasonal infrastructure to many communities in Ontario and across Canada. So here's just a small snapshot of Ontario, some of the ice roads that are used. So you see that there's a lot of these remote communities. A lot of these are Indigenous communities in Northern Ontario. And these seasonal winter roads are here in the dotted red line. So why are ice roads important? It's a lot for transportation. You get your essential seasonal infrastructure. It's a cheaper method of transporting large and heavy goods. So maybe you're building a house or something. It's way cheaper to move those goods across, 5 kilometers of frozen lake during the winter when you can drive it there, as opposed to barging where you're looking at, $600-800 one way just to travel 5 kilometers. That's it pretty quickly. So climate change impacts the integrity and availability of seasonal ice roads, which could impact community physical, social, cultural, and economic vulnerabilities. If climate change trends towards unfavorable winter road conditions, an adaptation strategy is going to be needed in response to the impacts that climate change is going to have in the future. And those are some things that we need to start considering earlier rather than later so that we're prepared for them in the future. So what else do we consider? Maybe something a little less long-term than ice road integrity. We're probably going to have an ice road next year, but who knows if we're going to have an ice road 50 years from now? Maybe the climate's going to change so much by that time that ice roads are a little bit more unfavorable. We're not sure yet. A pressing issue in remote communities is winter storms. So conditions often lead to situations where major highways such as the Trans-Canada Highway, and this is Highway 11 here in Northern Ontario, are shut down for significant amounts of time. So back in the winter of 2019 to 2020, Highway 11 was shut down in Temagami overnight, and this resulted in hundreds of people being stranded up here only with their vehicles. There's very limited accommodations. So, we have to make sure that we have infrastructure available in Canada to, help and accommodate people for when these large snowstorms or other weather events happen. So, and I'm from Southern Ontario, so I was pretty shocked when I came up to Northern Ontario and saw how often we actually plow the roads here. It's a lot less in Northern Ontario, and I think this leads to a lot of issues in terms of safety and road conditions. So maybe in an adaptation strategy, we need to increase the amount of road clearing in the future. So Something else that we can consider that's a little bit closer and we see every year that has to do with weather is the spring freshet and flooding. And there's several aspects in here that have to do with, snowfall and temperature. Flooding is detrimental and can cause huge amounts of property damage. And we need to worry about flooding during the spring freshet. Spring freshet is like the spring thaw, and over the winter, the snow builds up. And how does the weather affect this? So this is just something that we have to consider. And people who operate these dams, so in Northern Ontario here, this is Ontario Power Generation, they go and they characterize the amount of snow that's on the ground in different areas so that they can predict how much melt we're going to get during the spring freshet. And this will tell them like how much they need to lower or just lower the water level in these like receptacle basins so that melting water has somewhere to go. So there's a lot of science in there to make sure that other communities don't get flooded out and everybody's safe. And it's not all just about cold weather and snow that we need to look at when we're thinking about climate change and what we have to consider in the future. Other impacts weather and climate have are drier summers. This impacts food security for everyone and increases the risk during fire season. It's good to know ahead of time if we're going to be experiencing a hot and dry summer without significant rainfall. We've been practicing forest fire suppression for some time now, so forest fire fighting, meaning that the duff layer is not naturally being burned from time to time from those smaller fires. So what happens is that duff layer in the forest builds up and we get like these more intense fires because there's more of that material to burn. And we're starting to hear about forest fires more and more, and they seem to be getting more severe. There are some species that do require fire and heat to reproduce. That's something like a jack pine, which its cones only open up when you get that heat, and that's how they spread and reproduce. It's part of that system. But forest fires are something that we have to be concerned and cognizant about, just how they impact the economy, the environment, and jeopardizing the safety of people. And then, so there's a lot of weather impacts, and bringing it into the conversation in a relatable way is hopefully something that encourages people to learn more about meteorology, climate change, and the interactions between, weather, climate, and what adaptation and mitigation methods we probably need to start planning earlier rather than later. And that's it. Thank you.
Well, thank you so much, Alexandra. You gave us a lot of insightful information and a lot of food for thought. Thank you to all our three panelists. We will be diving into a bit more of a discussion and questions and answers from our panelists. So before we get to that, though, we're going to have a little bit of a fun segment here. So this is called Some Questionable News. A bit of a test here, but not to worry. So with questionable news, we're going to see if we can differentiate between a real headline and a fake one, or what I sometimes call flake news, F-L-A-K-E, flake news. So in this game, we'll break down what makes a headline questionable, what the science actually says, and whether it's, just really clickbait for the internet. So feel free to play along with us and chime in with your comments, and we'll test our panelists as well. So we're going to get into some of those questions now. So the first one, use your Wordle skills to predict weather in Cloudle. Is this real or is this fake?
I hope it's real.
Yeah. I feel like it's real. I mean, that's a very newsy headline coming from a newsroom. I'm not sure what Cloudle is, but I'm going to go with it's real.
Yeah, I've never heard of Cloudle either, but maybe that's something that they're trying to get trending. So I'll go with real.
I want to believe it's real.
Okay, so we have 3 for real. Well, ding, ding, ding. This is a real headline. Confession here, I have never played Wordle. I think I'm probably the only person on the planet who has never played Wordle. So this is a new game challenge to challenge your weather forecasting skills. Cloudle gives you a random city, and you have 6 tries to guess the weather for the next 5 days, whether it's clear, cloudy, drizzling, rainy, or thunderstorms. snowy, or misty. So yes, look for cloudal and perhaps test your skills in weather forecasting for a random city.
Interesting.
Kind of sounds like fun.
Yeah.
Another challenge. I'm not sure. I don't think there's a prize. But anyway, so this next headline here is, so quote unquote, the calm before the storm, balmy temperatures coming up before apocalyptic second winter hits. Is this real or is this fake?
Such a classic newsroom headline. I'm going to have to go with real. I mean, somebody probably used it last week.
I'm going to say it's fake. I feel like it sounds very, very dramatic.
I'm going to go with fake too.
Ooh.
2 for 1. 2 against 1. Well, this is fake.
It could be real though.
Yes, there's a lot of clickbait on the internet, just trying to grab our attention to see if we can click on it. So yep, this one is fake. So next one, this is a fun sounding one. Let's see if it's real or fake. Oh hell no! Weird weather hammers Metro Vancouver. Real or fake?
Real.
Real.
I'm going to say real.
Ding, 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 ding. This is real. Just very rainy. Just April 12th. This was referring to the weather conditions on April 12th when there was, I guess, everything and the kitchen sink.
And the kitchen sink.
Yeah. And like Joanna was mentioning, in her presentation, the last 10 months, we've seen, extreme weather in British Columbia. So they seem to be in the headlines very often these days. Hopefully for better things to come in the future. And we'll all be working on that. So our next headline, but it's raining isn't a reason to call in sick. Is this real or is this fake?
Oof, I'm going to say real.
I'm going to say fake. I better pick one fake one.
I'll go with fake too.
Da, da, da. This is real. Just a very rainy day in Montreal. So, well, that was definitely a lot of fun. And, headlines have really been, challenging over, the last few months or so, especially with the distractions and social media trying to get the attention of the public. So that has certainly been a challenge. But yes, real or fake. So that was some fun. So now, of course, we are going to dive into our question and answer segment, where we're going to be fielding the questions that are coming from the viewers. But before we get into those questions, I have a bit of a question, though, for each of our 3 panelists. And I'll start with Alexandra. And this is just, based on just with your presentation from today. If there's one takeaway that you'd want the audience to remember, what would it be, Alexandra?
I think I'd want us to plan ahead very consciously for, what's going to happen with climate change. And I want us to look at and better understand the science that is out there. So we need people to look at that science and put that into words that are more accessible for the general public.
What about you, Nevin?
Oh, I agree with a lot of that. Yeah, I think communication is going to be key, and I think that as the science is very certain on climate change is real, but I think making sure that it's communicated properly is still going to be a big thing coming into the future.
Johanna?
Yep, we're totally all on the same page. We are just going to see more extreme weather events, but communicating the science of that and making sure our audience, whatever that audience looks like, trusts that we are giving you the facts and the latest science is going to be so important.
Okay, well, on that note, one of the questions that has come in, how do you know if an extreme weather event is affected by climate change? And I'll pose this question to Johanna.
This is a great question. when I first started in the Weather Center 15 years ago, meteorologists definitely tried to stay away from climate change. And, I remember when we'd get asked that question, we'd all sort of say, well, you can't take one weather event and connect it to climate change. You have to step back and look at a bigger trend. And that is still true, but the baseline of weather has shifted. Our seasonal averages have all shifted in the past decade. Our Canada's average temperature has already warmed 2 degrees since the Industrial Revolution. So, every day our weather has already been impacted by that shift. But what I'm really excited about is that scientists are able to rapidly connect an extreme weather event to climate change, which is something that we're seeing more and more. For example, the big heat dome that we saw out here in the summer and the floods, we had a group of climatologists use climate modeling to say that heat dome was 150 times more likely to have happened because of climate change. And I think that tangible connection and putting a number to it is going to be really important for people to make that connection. So I'm hoping that we see that more and more after a weather event. Climatologists are able to tell you exactly how much more likely that was because of global warming.
Yeah, I remember many decades ago when the topic of global warming and climate change was becoming more and more, prominent. In the community, the focus was always on, sea level rise and the effects to smaller islands. But now we are seeing that it's not just about sea level rise. It's affecting us whether you live on the coast, whether you live inland. It could be in the form of extreme rainfall events or, the heat events. So certainly it is something that we all have to consider because it's going to be affecting all of us. So the next question, I think I'll pose this one to Alexandra. What are some of the climate change mitigation strategies that we can implement, especially for your community?
Yeah, so something that people are always concerned about up here is the cost of travel. And that's something that we are going to have to plan very far ahead in the future because we need additional infrastructure to have, if people are going to switch to electric vehicles, which is, the plan for the country to have everyone switch over to EVs in the next 10, 20 years, something like that, or at least be considering it. So we're going to need to have that infrastructure put in. It's an island community, and for about 1 to 1.5 months at the beginning, and then again at the end of the freeze up season, those vehicles have to sit there in the cold, and it often gets to, negative 30s into the low negative 40s here. So it's cold, and those vehicles have to retain charge, and you need to be able to drive them out to the main highway again to another charge station at some point. So that we need the technology to get a little bit better in EVs, and we need to make sure that we have the infrastructure to support them in Northern Ontario. Charging stations are not that frequent up here. We have some in North Bay, which is about an hour and 15 minutes south. But then when you get to Tamagami, there's only 2. After that, you have to go another hour to about New Liskeard. So when those things get, more abundant, that would be great. But we also have to consider things like retrofitting our homes so that they are more energy efficient, they retain heat better, they're not as warm inside, so they have air conditioning during the summer, that sort of thing, because you have considerations for people's health, their safety and well-being during these times of the year. So those are some things that we can do to help adapt as well. For large-scale mitigation, that's more of a global thing. Everybody needs to reduce their GHG emissions. Canada's actually a pretty large emitter per capita here. So everyone needs to do their part to help everybody in the world there.
Yeah, definitely very important. Thank you so much for everyone to be involved. And I think that can be sometimes daunting for, many individuals where they may see it as something that is very overwhelming, and perhaps they might not be able to have such a great impact, but everyone's actions, whether big or small, can certainly help. So I've got a next question here, and this one I'll take it back to Nevin. This one was from your presentation where you showed the storm cloud. So this question is one of the viewers wanting to know, what is the name of that cloud?
Yeah, really, really good question. So that storm is what we would call a supercell. So it's a rotating thunderstorm, and it's the kind of storm that produces the most violent kind of tornadoes. But in that specific kind of framed picture, I would say it's you're really seeing the mesocyclone and the wall cloud associated with that. So those would be the 2 things that I would call that kind of photo.
Okay. Supercell. Thank you so much. I'll stick with you, Nevin. Another question that has come in. Do you have any tips for spotters on rain-wrapped tornadoes?
Oh yeah. Yeah, so that's something that's very dangerous when you're chasing, and if you're in the path of the storm. If you can't see the tornado itself, it's very hard to avoid it. So I would say my tip is to not chase very closely if you're kind of faced with a rain-wrapped tornado, and using a lot of those tools and having that experience and a knowledgeable driver like Sean, he usually keeps us out of those kind of hairy situations.
I know I think, I can't remember the exact year, but there were very prominent storm chasers, who were sadly killed in, I think it was a rain-wrapped tornado. They worked for National Geographic, so a very scary situation there. But I understand a lot of storm chasers, they have very good cameras that they can zoom in and perhaps get a close-up shot without having to be, very near and within danger. Thank you so much for that answer. So this next question here, I will pose it to Johanna. With atmospheric warming and thunderstorms rising higher in altitude at their peak. So I think perhaps the question is about maybe warming temperatures and how that affects, thunderstorm development and the altitude to which they rise.
Yeah, that's a really interesting question because, as you know, then that you need warm air for any formation of clouds. You get that rising air parcel that leads in cloud formation. And the more rapid we see that rising, the higher the tops of those cumulus clouds. And that's where we get those thunderstorms. So it's an interesting question. Does atmospheric warming mean that we're getting perhaps higher thunderstorms if higher levels of the atmosphere is warming? And I know, as Nevin sort of alluded to, the connection between climate change and severe weather isn't as obvious as the connections that we have to other extreme weather. As Alexandra was saying, we know we're getting hotter, drier wildfire seasons. We know we're going to see more flood events, but it's not as straightforward with severe weather. And that's because we're definitely going to have that one ingredient increase, which is warmer temperatures. But the other ingredient, which is wind shear, which is when we have a change in wind direction or wind speed as you rise, that's the other key ingredient to thunderstorms. And we don't know exactly what climate change will do to that ingredient. So this is a really a current topic that climatologists and meteorologists are looking into. There's some suggestion that, it might not necessarily mean bigger and stronger summer storms, but it is changing the season. In the US this season, we saw, Nevin, I know this is your bread and butter here, but we saw winter tornadoes like we never have before. And that's a possible trend when it comes to climate change, is the season is changing. And we might see severe weather outside of what we consider summer severe weather season. But yeah, Nevin, feel free to jump in.
Yeah, I think that you nailed it. And I think that for me, it's always like it's evolving science still. There's a lot of research still going on, and it's trying to keep up with that is pretty hard too. The way that I paint it in my head is like for thunderstorms is the storms themselves. It's not really the storms themselves, but maybe it's the probability of some of those storm events happening. And then as we've seen though too, it's other things like rainfall could be more intense in some of these storms too. So.
Okay, so we have another question here coming in. I think I'll pose this one to Nevin, the storm chaser. How prevalent are tornadoes in the southern hemisphere versus the northern hemisphere and elsewhere in the world?
I like this question. North America is pretty unique in that we do, I think, get the majority of them, but we're not exclusive. So they do happen in South America. Even last year, we saw a lot in Europe and in places that we haven't seen before, some of these storms. So I think that's another interesting thing to research with the climate changing and things like that.
Definitely so. I have a comment here for Alex from Dan Mongrain. He says, "Hi, Alex. We are in breakup soon and with possibly a week of safe travel."
Excellent. Sounds like you had a long ice road season this year. I think we went from the end of December until, I guess, about now.
So on the topic of the ice road, Alex, I wanted to ask you, in previous years, have you noticed, or the members of the community in Temagami, have they noticed significant changes from years past with the ice road, whether it be the timing of formation or melting, or the thickness of the ice compared from past seasons to present?
Yeah, so we don't have a lot of long-term data on that, but community members have, talked a little bit about how the time the ice road goes in changes a little bit. So my first year up here in 2019, it was about November 13th, and we went out and there's like 3 inches of ice already out on the lake there in some areas. And, that was very surprising because in years after that, we didn't get ice that early. And we were, people were told to, stay on the island beginning of December. There's no on and off. And I know this past year, people were able to, keep getting groceries into about mid-December there. But, in 2019, that was a no-go. My coworker, she actually couldn't go to a conference with us because, the ice was so thick already. So, it does vary. And I think it's something that we need to keep a better eye on. For the ice road, you measure up until it gets to a certain thickness, and then you would stop measuring until, the weather changes and starts warming up, and then you would start measuring it again, just because it becomes a little bit redundant, I suppose. And you know that the ice is already safe when you're, driving on, 2 feet of ice already. Like that's pretty significant, and you can bring quite heavy loads across on that. So yeah, something that I hope that the community keeps an eye on moving forward, and we keep good records and can compare. And yeah, hopefully they're able to have an ice road for years to come.
Hopefully. Thank you so much. I have another question with regard to what you were talking about with fire suppression. How often is this done per season?
How, like when we're fighting fires?
Yes, with regard to sort of the mitigation when you are actually being proactive in the fire season.
Okay, so that's a province of Ontario thing. Not something that I have done myself or that we've really done. We just research it and we observe what they're doing. So
Okay.
before, in more natural times when we didn't have this amount of firefighting capacity in Ontario, you would get smaller forest fires, and they'll burn out the duff layer. But because we're fighting forest fires so much now, we're kind of like beavers. Like we artificially change our environments. Beavers put up dams. We put up dams too. But now we are fighting these forest fires that naturally would have happened. And when we do that, it's kind of like cumulative effects of a lot of things. But that duff layer is building up because it's not burning. So now you have more of these like little leaves and twigs and dry debris that, will go up in flames, and they'll go up really quickly because they're not being removed, the way they were naturally. And then, it's multiple different things affecting like how frequent and how intense the forest fires year. That's only like one small aspect of it. We have to look at, what are the temperatures, like how's climate change affecting that for the future? And like how much like rain are we getting that season? So there's a lot of things that we need to consider in there. But that forest fire suppression and burning the duff is just kind of a natural thing that doesn't happen as naturally anymore because we stop it.
Okay. Well, thank you. Next question coming to us. I think I'll pose this question to Johanna. And perhaps Nevin, you can also chime in as well. Would making tornado warnings smaller and more like the US tornado warnings make it easier to warn communities rather than our current region-based warnings? Johanna?
Yeah, that's an interesting question. I'd be interested in your thoughts too, Nevin, because I think you're alluding to the fact that the National Weather Service has much smaller regions, and when they warn for a tornado, they really change that warning as the storm progresses. They issue that watch early, and then Environment Canada uses the same concept, but our regions are much larger. What I've noticed is that in the text of those warnings, Environment Canada forecasters do really get into where that cell was spotted, what communities are next, and they continually update that text. I know the topic of communicating weather warnings to Canadian audience is something that Environment Canada is thinking about right now. They want to think about ways to get that message across in new ways. They're experimenting with social media. I think they know that the way that Canadians are taking in information, whether it's through weather alerts or, the new national alerting system, it's changing. That landscape is changing, and they need to stay on top of that communication. So that could be one solution. I know they're looking at overhauling. So it's an interesting time for science communication for sure.
Nevin?
Yeah, that's really interesting. I think you said everything I would have said. The only thing I would focus on that question a little bit is make it easier. And I would say forecast or trying to pinpoint tornadoes and warn people is not easy. And so I know that they're definitely dedicated to doing the best job they possibly can and making sure that people in the path of those storms are warned. And I definitely trust them to make the right decision, however they progress.
Yeah, and I think this is exactly where storm spotters come in, because like Nevin, you were saying in your presentation, those that first say few hundred meters or so close to the ground, the radar isn't giving us any coverage there, so we can't see what's happening. So storm hunters, storm spotters, and even the general public, on Twitter or any sort of social media, presenting what they are seeing on the ground certainly gives us and gives Environment Canada a good idea of what is actually happening, and that can assist us well in warnings in a particular community and in a localized area.
We need you.
Yes, Nevin. Okay, so we have another question here, and I'll pose this one to Johanna. Why have this month's Colorado lows been moving northwest once they cross the Canada-US border? And is this normal, or is it a result of climate change?
I love how knowledgeable our audience is on weather. This is a great question. Yes, just briefly, Colorado lows are what we call big low pressure systems that form in Colorado, and they ride the jet stream north of the border. That's being the culprit for the big blizzards, plural, that we've seen in Manitoba this year. But you're right, the pattern has been they cross the border and then they sort of retrograde a little bit westward and they sort of stall out. I think we have to look at a multitude of factors. One of them is La Nina, that the cooler than normal equatorial Pacific waters generally means a more active storm pattern across central Canada. So I think that is playing into the weather that we've seen this spring. We very much have a La Nina in place. But one of my favorite topics right now, connecting weather and climate change, is the jet stream. And there are more and more studies showing that as the Arctic warms faster than the mid-latitude areas, that temperature difference is decreasing, and it's the temperature difference that fuels the speed of the jet stream. So without that fuel, the jet stream is becoming lazier and loopier and stalling out more, and that may be one of the reasons why we're seeing more prolonged weather events all season round. It's a topic that I'm really interested in, and I think we're going to hear a lot more about it in the years to come.
Johanna, I will ask you, does climate change make it more difficult to predict the weather?
I would say yes, Alex. I would love to talk to you more about this. Yeah, it's been interesting. In some cases, it's almost like, a lot of our models are based on historical averages and the climate as we know it. And I find sometimes, even when I'm looking at the heat domes, these long stretches of drought that we see on the West Coast, after 7 days, the model keeps trying to bring a system in because historically we do get these little Pacific lows that end the drought. And then you get closer and the model's like, actually, that's not going to happen. And it keeps correcting and correcting. So I'd say our mid-range forecasts are getting more difficult with climate change. And we're still figuring out the impact between the two every day. And I definitely think it's making more challenging. At the same time, our supercomputers are getting better. Our initial conditions are getting better. So I'm hoping that, it's sort of catching up as we go.
Yeah, certainly. So I know our chief meteorologist at the Weather Network, Chris Scott, he tends to describe, climate change as a soup where there are so many different ingredients, already melted into the soup. And while you taste the general flavor of the soup, it's really hard to pinpoint what the specific ingredients are sometimes. Yeah,
like
that was his description of it. In the soup, You've had, lots of ingredients, but what am I tasting here? Is this the dominant, ingredient that's coming forth? So certainly one that we will continue to monitor as well. So I have a question here, a bit of a curiosity for Nevin. I've never seen a tornado myself, and a lot of people are fascinated by it. And usually during tornado season, there are storms that are happening, and a lot of people are probably trying to chase themselves. What would be the one piece of advice that you can give to someone who is starting out storm chasing?
Well, I would say there's a lot of good resources, and building up that education was key for me. So I actually took meteorology classes, and having that foundational understanding of the atmosphere and respect, I think really helped my storm chasing in saving me from replacing a few windshields, and also just enjoying the chase more and being safe the entire time. So, and start small. Like if there's just a local thunderstorm in your area, like that's sub-severe, you can still have a good time and kind of see it from different angles and chase, right? You don't have to go to Tornado Alley for your first time storm chasing.
Start small. Definitely some good advice. I have a question here for Alex. With climate change so prevalent, can we expect, oh, really, that's not the question. Here's the question for Alex. Sorry. With this climate change, is there any study or observation with regard to animals, flora, and fauna in Temagami or the surrounding area?
Yeah, so there is a lot of data on the species that are here now and where they're migrating to. And I just want to highlight something that might be relatable for everyone. So everybody is aware of what Lyme disease is and how it's transmitted by ticks. And that's not something that we've seen a lot of in the Temagami area. But what's been happening is the conditions here have been warming a little bit, and we don't get that sudden cold that, kills off a lot of these like small insects and makes it unfavorable. So the conditions up here have actually been becoming more favorable for these southern species to move up. And what that's called when these species shift northward is a range shift. So they're shifting into these areas that have now become accommodating for them, that they can survive in. And when you get new species moving in, they can bring things like disease, such as Lyme disease. And that's something that the health unit up here has been aware of. They've been doing tick drags over the summer. So there is research and there's monitoring going into that. But we're also looking at other invasive species and other species that might be coming up north. So something that also goes with shifting ranges is, if you're not familiar with the Temagami area or Northern Ontario, there's a lot of logging that goes on in these areas. And the species of trees that are being logged, we replant after the trees are cut down. And the government or the people who are replanting these trees use something called assisted migration to help create, hardier forest for those future environmental conditions. It takes, 50 years at least for a tree to grow so that it can be harvested again in the future. So we're not just looking at what is the climate going to be in, 10 or 20 years. It's going to be, what is it going to be in 50 years from now? So we need to make sure that the selection of species or the gene pools that are replanted here are appropriate for what those future conditions are going to be, so that they can survive to maturity to be reharvested. So there's tons of research going on. There's tons of information that we could talk about forever.
Okay, so I have a question here for Johanna with regard to the younger generation, and having written several children's books. In terms of, communicating science to the younger generation and to kids, how would you say would be the best way to start, given the fact that a lot of the younger generation may have a bit of apprehension or fear about climate change and how it will impact them as they move into the future?
That's such a good question, because I am seeing the younger generations, especially high school students, have this eco anxiety, this environmental anxiety that I didn't necessarily grow up with, and it's not just fears about their future; it's translating to fears about weather. It's been really interesting to see that be a big part of the young generations right now. So I would say, when talking to them, first of all, it's listening. Where do those fears come from? What is their own situation when it comes to climate change, and really letting them talk about what it is that they're scared about, and then changing that fear. As Nevin said, a healthy level of fear is definitely important, but I think understanding the science behind climate change and the connection to weather in a way that younger audiences can understand gives them empowerment. And I think the more information and knowledge you have about something that scares you, the less that's fear, and the more you feel like you understand it and maybe you can do something about it. So it's sort of listening, helping them understand the science of what's happening, and then giving them options when it comes to being part of the solution. And I don't think it's a one-size-fits-all solution. What I'm hearing a lot about talking to environmental psychologists, which is a growing field, is that being attached to some kind of a solution, depending on your personality, can really help with that anxiety. So, whether it's being a part of a neighborhood project to plant more trees, or it's showing up to rallies if you're more of a social person, and finding ways to connect your audience is really important. When I'm talking to really, really young audiences, which is where my books are pointed, I like to actually anthropomorphize things like clouds and pine cones. Actually, my new book coming out, Alex, I love that you brought this up, is about a Jack pine cone who needs wildfire for her seeds to open up. So if you're talking to really young audiences, it's making a fun story about it while taking them on a science journey. But I'm always open to new ways to talk to young people.
Yeah, I think that's really important. Thank you so much, Joanna. The sense of, our personal empowerment that we can help mitigate, and perhaps it might not seem or be as daunting if we can be more proactive. Thank you. Next question, I think I'll pass this one over to Nevin. So the question here is, I've often seen a dark ripple, quote unquote, in clouds before a thunderstorm hits in Regina. What is this caused by? I'm not sure what the dark ripple refers to.
Yeah, you need to send a picture, but I'm assuming it's if I'm imagining like Regina and the storms that come through, there's a lot of like shelf clouds or like large kind of boundaries between two different air masses that kind of come through when these storms come through, and you can get some really spectacular striations, we call them. And so I'm thinking that's what maybe it's kind of like, okay, ripple is like a butterscotch ripple in a vanilla ice cream. Yes, striations. Yeah. So yeah, that's a good way to describe it. Some of these storms, if they're supercells or even really big shelf clouds, can have these kind of like pancake stack looks. And I think that that's just from that wind shear that we talked about a little bit, and how it's working with the storm kind of creates those lines, which is really cool to see. So it's one of the reasons that draws me out there as a storm chaser, for sure.
Well, thank you so much. I have a bit of a question here, just on my own curiosity. When you're chasing storms, or in your history of chasing storms, how many tornadoes have you documented?
Oh, yeah. Our team tried to count at one point, but we lost count, I think, at 200. So, yeah.
Wow.
That is impressive. That is definitely impressive. How long have you been chasing storms, Nevin?
Me personally, I don't know. It's always hard to pick exactly when it started, but probably over 12 years. And yeah.
That is definitely impressive. Well, we've had some great questions that have come in, and it was definitely a very lively and educational discussion. And I would like to thank our three panelists, Alexandra Clark of Temagami First Nation, Joanna Wagstaff of CBC, and Nevin of Prairie Storm Chasers. Thank you so much to the three of you. And we look forward to collaborating with you, in the future, and all of the good work, and looking forward to that book, Joanna.
Thank you.
So at this point, I will pass it over to Suzanne, our chair.
Oh, well, thank you so much. Thanks to all four of our speakers for sharing your expertise and your personal experience. I thought that was really interesting to see how you all got into the field, and also our audience for great questions. Some of you asked exactly the question that I would have asked. So it's wonderful. So we hope you enjoyed our discussion today as much as we did. And please share your feedback with us and let us know what you'd like to see from us in the future. There's a link in the chat box. And if you can, consider supporting RCI Science's free programming. Visit rciscience.ca/donate for more information. Next month, we're delving into the science behind cosmetics with the amazing Science is a Drag team. It's going to be awesome. You can find out details about all of our upcoming events on our website, rciscience.ca/what's on. And if you want to get earlier updates on what's next, please subscribe to our newsletter. There's a link in the screen and in the chat box. And thank you so much for joining us today. Happy spring, everybody. Bye.